Hello. Hi. So, before we go into anything in database, let's talk about how dependencies work in database. What is functional dependencies database in database is really important. Now, the idea of functional dependency is simply that in an entity, one of the attributes defines or points to the other attribute. So, if you know this, you will find this very easily. That's the idea of primary keys as well, right? These attributes are called keys or primary keys, which point to other attributes which are indexed upon, and you get the other attributes like that. For example, in this relation that we have the name and the ID. Now you can see there are two names that are repeating. If I say I want the name, or let's say there are some more fields out here, I want some fields for Jack. But which Jack am I talking about? I do not know, right? In that way, we can go back to the ID which is indexed, which is the primary key. We can, from this ID, we can figure out which Jack or which person that we are talking about. And this is called, this dependency that we have of the entire record being dependent on one particular key, right? Could be a primary key, could be a composite key as well, but that dependency is called functional dependency. And it has three different ways of defining. Any database or anything has three ways of defining dependencies. First is partial, second is full, and third is transitive, which ideally is not needed ever. Okay, and even this is not needed. I'll tell you. When you learn normalization, you will understand these two have no meaning actually, but to do or normalize a table, normalize a entity that you're creating, and you need to understand what kind of dependencies are there. That's why we are doing this. So let's go on to partial. Now, partial dependencies are simple enough. You can understand from the term itself that the dependency is partial. For example, if you take a relation like this of, let's say, an exam marks, right? And the marks are defined on top of two bases, right? We have the student roll number and the subject ID that their marks are. So let's say that we have physics, chemistry, maths, and biology as subjects over here, and we want to find out the marks of the student with roll number 1 with or for subject physics of ID which has ID 1. So through this combination we can find the specific marks, right? Then this combination is called a composite key. This combination is called a composite key. Now we have, you see over here, another column called subject name actually. Now this subject name does not depend on the roll number at all, on the roll number field at all, right? It does not depend on roll number field, but it depends on the subject ID. That is the only way to find the subject name. We don't care about the roll number because this subject ID will be repeating throughout this table. The table might have multiple student roll numbers, and multiple subject IDs, and their combination with different mark entries, right? But the subject name is dependent only on the student ID. So in this relation, you can see we have roll number and subject ID as key, but our subject name is only dependent on the subject ID. This is called as partial dependency, which is not needed in a normalized database, which should not be present in a normalized database. But to identify and remove it, you need to understand what is it, what you are looking for. So this is a partial dependency, and now you understand. We'll come back to full dependency. Full dependency, very simple. We take the same example. We know this is a composite key, right? Even though subject name is dependent on subject ID, we know that marks is only dependent on this whole composite key, right? Without knowing the roll number and the subject ID, we cannot find out this number over here, this field, or what exactly value we are looking for. We cannot find that out. And since that is the case, we know that our composite key, roll number, and subject ID. So our marks column, our marks attribute, let's say, is completely dependent on this whole key. which means it is fully dependent on, and this is called full dependency or full functional dependency if you want to call it, right? The third part, which again is important to identify, is called transitive dependency. You may have learned in physics or maths transitive dependencies, like if A is to B is to C, then we can say that A is to C. That's the same logic that you have to do here. Now let's say I have this table of student address, right? Student address, and I want to find out for roll number 1 which city they live in. So I can just know, this is the primary key. I can find from roll number 1, I can query where roll number 1 get me the city, and we'll get XYZ, right? But you see another field in the table called pin code. Now pin codes, as we know, in the real life world are unique, right? They are unique. So from, if I do the same query again, something like, let's say 401 get me the city, I'll get XYZ. Now what happens here is, we know these three are related to each other. So we can know that when we do roll number 1, we can get XYZ, and if we have the city, we can have 401 as well. Or if we have 401, we can get XYZ, we have 1 as well. So in this same format that we have here, 1 is XYZ with 401. We know 1 can be, we can find 401 from 1. And both of these are not non-key attributes, both of them. They are not key attributes, they are not primary attributes. This is called transitive dependency, which violates the normalization rules actually. So in that way, we need to understand in these three things, these three dependencies are the one we need to understand, and to normalize the database, to know which dependency our table or our entity is going through, so we can remove it and we can make it have the full dependency. And that's the video. Thank you for watching, and let me know if you have any doubts or queries in the comments, and I'll be able to solve them. See you next time.